Describing motion. We shall now learn how to use the universal language of mathematics to understand motion and rest in the simplest possible way. Motion in one dimension. Let us imagine a scale on which the distances are measured in successive points or steps, and each point or step is separated from the next one by 1 meter. When we start our observation, we see that our object of interest is at a distance or separation of 3 meters from the reference point. Our assumption is that the object is constrained on this scale. What that means is it can move back and forth on the scale, but not in any other direction. It cannot go sideways and it cannot go up or down. We keep observing this object. The stopwatch in our hand keeps ticking away, but the separation of the object from the reference point remains the same. At the end of the observation, we halt the ticking stopwatch. We note that the final value of separation of the object from the reference point is still 3 meters. We note the time recorded in our stopwatch. Now remember, the object is free to move back and forth along the scale. Now, borrowing a concept from mathematics, we will consider any movement to the right as a positive separation and any movement to the left as a negative separation. We are for the moment only interested in the initial and final separation of the object from its reference point. In other words, it does not matter for how many times the object went back and forth. All I want to know is where the object started and where it finally ended up when I stopped measuring the time. The previous thought experiment gives us the definition of displacement. It is the shortest possible distance between the initial point when we started the stopwatch and the final point when we halted the stopwatch. Please note, we are not really concerned with how we ended up at the final point, only its value and the elapsed time. This becomes important later. Let us say that you began at a separation of 3 meters from the reference point. When you halted the stopwatch, your separation from the same reference point was 9 meters. The ratio of the change in your separation from the reference point, which henceforth we shall call displacement, to the time elapsed, the stopwatch reading, gives us velocity. Having seen this simple example, let's make things a bit more complicated. Let's say that the object first changes position from 0 meters to 12 meters, then backtracks along the same line to 9 meters. We can ask two separate questions. Question 1. Where did the object end up at the end of the experiment if we are unconcerned with how it got there? In other words, the details of the journey do not concern us, only the starting point and the final destination. Question 2. What if we are more interested in the total number of steps that the object has covered, irrespective of the direction they are covered in? In other words, we are simply counting the number of steps, each step being 1 meter of separation, and are unconcerned with whether we are taking them to the left or to the right. The first question will give us the concept of displacement, while the second question will give us the concept of distance.